Mass and weight. In this topic, we are going to look at mass and weight and gravitational fields. Now, the learning objectives. You need to show familiarity with the idea of the mass of a body. You need to state that weight is a gravitational force. Distinguish between mass and weight. Recall and use the equation W is equal to mg, as well as to demonstrate understanding that weights and masses are compared using a balance. Now, take note that all the objectives that are underlined are for those that are doing extended. You're also supposed to demonstrate an understanding that mass is a property that resists change in motion. Describe and use the concept of weight as the effect of a gravitational field on a mass. State the gravitational field that it is a region in which a mass experiences a force due to gravitational attraction, and also use the equation W is equal to mg, where m is the mass, g is the gravitational field strength. Now we start off with talking about mass. Mass and weight are not the same, as they are mostly thought of to be the same. They are not the same. Mass is the amount of matter in an object, whereas weight is the gravitational field acting on an object. Mass is measured in kilograms. Weight is measured in newtons. Mass is measured with a beam balance. Weight is measured on a spring balance. Mass of an object is constant anyway in the universe. And mass is a scalar quantity, i.e. it is size only without direction. Now looking at weight. Weight is the pull of gravity, that's the force of gravity on an object. Weight is measured using newtons and not kgs. Weight is measured using a spring balance, like I've already alluded to, and weight varies from place to place because of the gravitational force that acts at different places. Weight is a vector quantity, i.e. it has size and direction. Now these are the instruments that are used to measure mass and weight. The triple beam balance is shown here. This one measures mass mostly. The electronic balance measures mass. They are all graduated in grams. And then we've got the spring balance. The spring balance is to measure the weight. Then we are going to talk about gravitational field strength. Gravitational field strength is the force of gravity divided by the unit mass that is acting at a particular point. The force of gravity on a 1 kilogram mass, that is, and it is measured in newtons per kg. To calculate the weight of an object, you simply multiply the mass and the gravitational field strength. So W is equal to mass times gravitational field strength. W being measured in newtons, mass being measured in kgs, and gravitational field strength measured in newtons per kg. So in short, you just say W is equal to mg. With a beam balance, the weight of a standard mass balances the weight of an unknown mass. Weight is proportional to mass. That is, W is proportional to G. W is proportional to M again. From that equation, W is equal to M times G here. So if this one is kept constant, that is, if the mass is kept constant, then W is directly proportional to G. And if this one is constant, that is here on Earth, G is constant, W is proportional to M. So which means that if this one increases by a factor, this must increase by the same factor as well. So the masses can be compared since G is the same for both weights. If you remember those weights, one weight on one side, other weight on the other side, you can compare the weights. You can add weights on one until you establish a balance. So that's what I'm trying to say here. Now in the examples here, the gravitational field strength on Earth is around 10 newtons per kg. So that's what we're going to be using in the IGCSE syllabus. We use 10. We do not use 9.81. Now, if the gravitational field strength is 10, then the question is saying, what is your weight if your mass is 45 kgs? Using this formula, W is equal to mg, we can then say G is 10, M is 45, therefore 10 times, so this 10 times 45 would give you 450 newtons. So that would be the answer for this one. Now I'm going to leave you to do these examples, 1 up to 13 that I've just listed here, and I'll do a video again to show you how each of these is done. So that's question 4, 5, 6, 7, 9, 10, 11, 12, 13. Now I'll end this lesson by comparing mass and weight. Mass is the amount of substance in the body, that is the amount of substance in the body, quantity of matter in a body, we can say. Weight is the force of gravity that acts on a body. Now, mass is constant at any location, whereas weight depends on the acceleration due to gravity at the location, that is the gravitational field strength. Mass is a scalar quantity, weight is a vector quantity. So you know what a scalar quantity and a vector quantity is, right? Mass is measured in kilograms, whereas weight is measured in